I've been doing fluid mechanics for well, longer than I care to to tell you, and I'm really interested in understanding the behavior of interfaces, and in particular in situations where you've got a high-speed flow going past an interface, and we want to understand what happens if that flow is turbulent, that it interacts with the interface. What happens next? How do you model that? How do you put that on the computer in a way where you can actually capture what happens in real life?
For example, like mixing in stirred tanks, like we know we need power to actually mix these fluids, and the amount of work you need to do, or the power or the torque, actually is a function of the shear stress, or it's again the boundaries that are playing the crucial role.
You have an impeller, you have water with the air on the top, you rotate the impeller, you have the interface that deforms, and then when you increase the frequency of the impeller, it deforms more until you reach the blade, and then you have a multiple of bubbles. So it's a process of mixing, and that's what I'm doing at this moment.
These simulations are useful in many different areas, in, say, pharmaceuticals and mineral processing, because a lot of industrial applications depend on the size and the interactions of droplets.
Basically, multiphase flows, this area that we're working in, which involves this issue of a turbulent phase flowing past an interface, is central to just about every processing equipment in manufacturing. So if you get that bit of physics wrong, then you're making all kinds of wrong predictions in designing lots of things which are important from an industrial perspective. And we think that that's one of the main reasons why there is a lot of inefficiency in design.